Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for May-June 2023, and the code is 9709/63. So let's move on to question number 1. Question number 1, a random variable x has probability density function f. This is the function, and this is defined from 0 to 1 inclusive both values. Find ex. Ex here is the expected value. So based on the definition of ex, it will be integrated from the given limits 0 to 1, x multiplied with fx. Okay, since there is a constant in the fx, which is our 3 over 2, so before I do integration, I will factorize the 3 over 2, and then I will just integrate the terms with the x. So it will be 1 minus x squared multiplied with the x. And then now, before we do the integration, now we have to do expansion first. So now it will be 3 over 2 integrate 0 to 1. So x times 1 will be x. Then x times x squared, it will be x cubed. Okay, and now we integrate both terms. So first term, the x with degree 1 becomes x degree 2 over 2 minus, then the x degree 3 becomes x degree 4 over 4, because for the integration we always add 1 degree and over the new degree. Okay, so now here, after you get this, then just replace the x by 1 first, the upper limits, then minus when it is lower limit. So I will get 3 over 2. Now for your information, 1 to any degree is still 1. Therefore, the first term, it becomes 1 over 2. Second term will be 1 over 4. Then minus when the lower limit is 0. So when the x equals to 0, both of the terms will be 0. Then from here, I will get 3 over 8. So this is our ex. For question number 2, a club has 264 members, numbered from 1 to 264. Donesh wants to choose a random sample of members for a survey. In order to choose a members for the sample, he uses his calculator to generate random digits. His first 20 random digits are as follows. So these are the random digits. A, the numbers of the first two members in the sample are 106 and 121. Write down the numbers of the next two members in the sample. So when you look at the random digits here, right, 106, this is the first member. Then 121 will be the second member. So now to get the numbers of next two members, it will be the next three numbers, 180, and the subsequent three numbers. Okay, so from here I will get 180, as I have highlighted using the red line. So 180, and another one with 121. So these are the two numbers for the next two members. Okay, now B, to obtain the numbers for the members after the fourth member. Donesh starts with a second random digit, 0, and obtains 061 and 211. Explain why this method will not produce a random sample. Okay, so let's look at the 061. So it means that now he starts with these three numbers. Okay, after that, 211. So these are the two numbers. Now, why this method will not produce a random sample? Okay, so it's because we are referring to the same numbers, right? Because these numbers are dependent on previous numbers. That's why he will not get a random sample. He should generate the new set of random numbers. Okay? So now question number 3. In a random sample of 100 students in Luciana's college, X students said that they like exams. Luciana said, use this result to find an approximate 90% confidence interval for the proportion, which is a P, of all students at her college who like exams. Her confidence interval had width. Okay, this is a width of the confidence interval. Now A, find the two possible values of X. So just for your information, 90% confidence interval for P, the formula is going to be P hat plus minus Z alpha over 2 square root P hat Q hat over N. So basically, this is the P hat. Okay, now this Z square root will be this. This is a Z together with the square root. And here is also Z alpha over 2 square root P hat Q hat over N. So that's why you are getting interval. Okay, this is the lower limit, this is the upper limit. And now you are given the width is this value, which means the width is here. This is the width. Okay, so based on this diagram, I know that width is actually double of the Z together with the square root. That will be the width. Okay, so now I will write width equals to double of Z alpha over 2 square root P hat Q hat over N. Okay, now what is my P hat? My P hat is the proportion for the students who like exams. So it's mentioned that X students out of 100 students like exam. So I will write X over 100. Therefore, the Q hat is going to be 1 minus P hat. Then I will get 1 minus X over 100. And if I make it to same denominator, it will be 100 minus X over 100. Okay, now the N will be 100. Then what is my Z value? So now you have to refer to the normal graph. Because based on here, this is normal critical value. So for the normal graph, right, now we are forming 90%. Okay, or you are given the width of 90% confidence interval, which means here is 90%, the middle, right? This is 90%. But then we need the area of the region towards the left-hand side, the green region. Now we know that the total region is 1, which means here is going to be 0.05. Right? Then I will know that the total green region is going to be 0.95. Now you can read this 0.95. What is the critical value when the probability is 0.95 from the table? So it is 1.645. Okay, so from here I will just replace all the values, which means you are getting 0.15792, which is a given width in the question, equals to 2 times 1.645, then square root of P hat is X over 100, then the Q hat is 100 minus X over 100. Then divided by the N is 100 students because it's a random sample size. Okay, then now from here, you need to find the X when you look at the question. Two possible X. So now I will move down this value to the left hand side. Okay, and then I calculate 2 times 1.645 is basically 3.29. So I'm getting 0.15792 over 3.29. That equals to the square root. Right? Now, when you simplify the square root, look at the question, look at the solution here. Here is over 100. This is over 100. Here is again over 100. Means that these three terms can be combined together. Alright, so I will move down the 100, which means I will simplify it into X times 100 minus X over 100 cubed. Okay? So from here, to eliminate the square root, because we need to find the X, we have to square both sides. So now I'm going to square both sides. The reason is to eliminate the square root. So the square and square root will be cancelled off from the right hand side, and then for the left hand side I need to do expansion. So now before I calculate what is the square of the bracket first. The bracket I will simplify into 0.048. Okay, then I will get squared. And then now once I have factorized, I have cancelled off the square root with the squared, I will get x bracket 100 minus x over 100 cube. Okay, then now this 100 cube will be moved up. So when I multiply, I will get 2304 equals to x. This one I will do expansion. So I will get 100x minus x squared. Okay, then now I will rearrange this to get a quadratic equation. So it means that I will move all the terms to the right side because I want to get the positive x squared. So from here you will get x squared minus 100x plus 2304 equals to 0. And then this quadratic equation can be factorized into two linear factors. So the first linear factor is x minus 64, and the second linear factor will be x minus 36, then equals to 0. So when multiplication of two factors equals to 0 means x minus 64 equals to 0, or x minus 36 equals to 0, which means my x equals to 64 or x equals to 36. So these are the two x values in the question. Okay, so now Susma independently took another random sample and found another approximate 90% confidence interval for P. Now B, find the probability that neither of the two confidence intervals contains the true value of P. Okay, not both. What is the probability that both confidence interval do not contain the true value of P? That's the question here. Okay, so from here we know that if 90% confidence interval, that means, right, 90% is the 0.9, I would say 0.9 is the probability of, or that the interval contains the true P. Okay, so now you need to find probability that not both of them contains the true value of P. So from here we know that probability an interval does not contain the true P. It will be 0.1 because 0.9 it will be contains it will contain the true P. So means that 0.1 means that does not contain the true P. Okay, so now we need to calculate probability two confidence intervals. Confidence do not contain true P. So one confidence interval, okay, look at here, an interval. If one interval, it will be 0.1. That is a probability. Now, because of two intervals now, therefore, we know that these two intervals are independent. Okay, so it will be 0.1 for the first interval, and the second one, it will be 0.1 as well. Since they are independent confidence intervals, therefore we multiply together. So that means you'll be getting 0.01. Okay, so the reason is because they are independent samples. Alright, so now for question number 4. The mass in tons of steel produced by per day at a factory is normally distributed with mean 65.2 and standard deviation 3.6. It can assume that the mass of steel produced each day is independent of other days. The factory makes profit of $50 on each ton of steel produced. Okay, this 65.2 and 36 is the mass of the steel produced. Okay, so now find the probability that the total profit made in a randomly chosen 7-day week is less than this amount. So now this is the profit. You need to count the probability of the total profit. And then this 65.2 and 36.3.6 are the mass. Okay, so be careful with this. Alright, so to solve this question, basically we have two methods. I'm going to show you both methods. Let's say the M is the mass. Okay, let mass equals to M. Alright, so from here I will write M is normally distributed with 65.2 the mean and standard deviation 3.6. So we always write variance. That's why square of 3.6. Okay, then now I will say this is per day. See, this is the mass per day. And now this is regarding 7 days. So it means that now I will get expected 7M to get the mean. So it will be 7, 6. I will write for the step-by-step working. It will be 7 expected M. It will be 7 times 65.2 and you get 456.4. That's the total mass. Then the variance for 7 days, the variance of mass for 7 days, it will be 7 variance M, because 7 days is the addition, not the multiplication. So then I will get 7 times 3.6 squared. Then you will get 90.72. Alright, so now from here we need to get profit. Okay, so remember each ton is $50. So from here I let my T be total profit. So my first working is regarding the profit. Alright, so now from here I know that ET, it will be $50 profit, okay, times the mean. Because if the mass is normally distributed, then the profits will be normally distributed as well. So it will be 456.4, then I will get 22820. This is the mean profit. Then the variance profit will be 50 squared, because it is $50 per ton, times 90.72, then it will be 226,800. Okay, so from here I will say that basically my total profit, which is a T, is normally distributed with mean 22820, variance will be 226,800. Okay, and now you need to count probability that the total profit is less than this amount. So now P, T less than 22000. Then now, since the T is normally distributed, that means I have to standardize it. So it will be Z less than 22000 minus the mean over, remember, this value, right? This is variance. We always divide by standard deviation because our formula is this. If X is normally distributed with mean, mu, variance, sigma squared, your standardized normal random variable will be X minus mu over sigma. Okay, so to get sigma from variance, we need to take square root. So 226,800. Okay, so now when you calculate this value, it will be a negative value. So it will be Z less than negative 1.722. Okay, so once you have found this Z value, quickly sketch the normal graph. The middle value is 0 because it's symmetrical at 0. And negative 1.722 is on the left hand side of the 0. Now the region here is less than. That means it's towards the left hand side. But then when you refer to the table, we are not given this left hand side region. The region must be right hand side. So I have to flip it. So when I flip, or probably I will just show it on the same diagram. Right? So when I flip it in the line 0, my region will be the green region. So I know that the critical line will be 1.722. Now remember, our original region is the blue. So in order to get the green region, it will be total probabilities, which is 1, minus the probability probability that z less than 1.722. Then I will be getting the green region. So green region is actually same as the blue region, because the probability means the area of the region. So here I will get 1 minus b, z less than 1.722. Okay, and now I will get 1.722 from the PZ less than 1.722 from the table. It will be 0.9575. Okay, so when you simplify this, it will be 0.0425. This is the probability to 3 significant figures. And I have told you that this is the first method, alright, because I'm using the profit to calculate the probability. Now, the second method is, okay, so second method, I can just change all to the mass, alright? So we know that we are considering 7 days, okay, here 7 days. So instead of using this total profit, I can convert this total profit is actually equivalent to how much in the how many tons in the mass, right? So I will rewrite my expected value and the mean for 7 days, the mass for 7 days first. So I will rewrite expected 7m, right? It will be 456.4. Then the variance of for 7m, it will be 90.72, because the calculations are here, okay? So you can just rewrite if you use the second method. Then now, I let the Tm be the total mass. Okay, so we know that the total mass is going to be the profit over, total profits over the profits per ton. So from here, I'm getting 440. Means that it's basically 440 tons. Alright, so from here, I will get Tm is normally distributed. The mean is 456.4 and the variance is 90.72. Then you need to count probability that the total mass is less than 440. Then now I will standardize this. It will be z less than 440 minus 456.4 over square root of 90.72. Okay, so when you count the value, it will be z less than negative 1.722. So when you compare with the previous working, it is here now. Okay, that means if you are using the second method, after you get this, you just continue with all these steps because we are here now. Okay, so I will not proceed because the working is exactly the same. So these are the two methods to solve this question. Alright, next question, number 5. Last year, the mean time for pizza deliveries from Pizza Pit was 32.4 minutes. This is a mean. This year, the time T minutes for pizza deliveries from the same Pizza Pit was recorded for 50 deliveries. Okay, so this is the N. And you are given the 3 values, these 3 results. A, find unbiased estimates for the population mean and variance. Okay, so for your information, the unbiased estimate for the population mean, which is a mu hat, it is same as the x bar, the sample mean. This is, okay, I don't use the x bar here because you are given summation t, so I will use t bar. So here will be summation t over n. Then it will be 1700 over 50. And last we are getting 34. And then the unbiased estimates for the variance is sigma square hat. The hat is unbiased estimates. Or I would say it is the estimated value. So this is same as the sample variance. Sample variance formula is 1 over n minus 1 summation t squared minus summation t bracket square over n. This formula is available in the table, in the formula list. So from here, I will just write 1 over 49 because your n is 50. Summation t squared is 59050 minus square of summation t, which is 1700 over 50. Okay, then from here you will be getting 1250 over 49. I leave it in fraction because I do not get exact value or whole number. I would say I do not get whole number. So these are my solutions for A. Now for B, test at 2% significant level whether the mean delivery time has changed since last year. Okay, so let's look at the question. So the mean time was 32.4. Okay, so that means my H naught, the mu is 32.4. But since you need to check whether the mean has changed or not, that means now your H1 is going to be mu not equals to 32.4. Okay, and you are testing at 2% significant level, therefore alpha is 0.02. Alright, so when you look at the question here, the data, the sample size is 50, right? So when it is 50 means it is a large sample. So when large sample, we will be using the z-test, right? So now I will draw the graph. I will sketch a graph. Then since it is not equal, okay, to t-test, therefore I have to shade my critical region, which is 2 t-test. Okay, the total region here, the shaded region will be 0.02 because the alpha is the probability to reject the H naught. That means each side will be 0.01. Okay, because 0.02 shared by 2 parts. And then now we are going to use a z-test. Therefore, for the z-test, we need the total region towards the right hand side because now I need to find what is my critical value here. So since the region on the right side is 0.01, that means the region towards the left hand side will be 0.99. Okay, then now we read the table, the formula, the normal table, and I will find that this is 2.326, and same goes to this. It will be negative 2.326. Then my rejection criteria will be reject H naught if the modulus of z is greater than 2.326 because it will be two-sided. Okay, and now I will show my calculation on the right hand side. So my z value is going to be t bar minus mu over sigma hat over square root n. Okay, so the t bar we have counted just now. T bar equals to 34. Right? So I will get 34. Then this mu, okay, here, this mu is the mu at the H naught. That means it will be 32.4. And this sigma hat we have counted just now. But just now we have found sigma hat squared. Therefore, we just take square root of this value. Okay, I will bring it in and change to square root. Means that the formula is basically same as this. Okay, so when I bring in the variance, the estimated variance. So from here, I will just write square root of. So the variance is going to be 1250 over 49. So here I will write 1250 over 49. This is my estimated variance. Then over the n. N is going to be 50. Alright, so from here, you will get 2.24. Okay, so once I get this result, 2.24 is basically before the critical line. So when it is before the critical line, it does not lie in the shaded region, which means my conclusion is do not reject H naught. Sorry, this is not the conclusion, this is the decision. Okay, so the decision is do not reject H naught. So for the conclusion, you have to look at the question here, whether the mean time has changed. Right, since we do not reject H naught means that there is insufficient time to conclude this. Alright, because we fail to reject, that means we have to accept 32.4. Alright, so our conclusion will be there is insufficient evidence at alpha equals to 0.02 to conclude that the mean delivery time has changed. Okay, so this is the full solution of this question. Now see, under what circumstances would it not be necessary to use central limits theorem in answering B? Okay, so we don't use central limits theorem, okay, to answer the B because the distribution is normal, right? So as long as you know it is normal, then it will not be, we don't need to apply the central limits theorem. Okay, so basically from the question here, it does not mention normally distributed, right? So that's why would it not be necessary to apply this? Means that the distribution of the delivery time is normal. Okay, so that's the solution for C. Now number 6, it is known that 1 in 5,000 people in Atalia have a certain condition. A random sample of 12,500 people from Atalia is chosen for a medical trial. The number having the condition is denoted by X. Now, A, find an appropriate approximating distribution to calculate this probability. So we know that 1 in 5,000, which means this is the P. Okay, so I will say P is 1 over 5,000, and then the N is 12,500. Right? It's mentioned you need to use approximating distribution. So from here, I will count what is my NP, because I know that my N is large. So my NP is 1 to 500 multiplied with 1 over 5,000, then it will be 2.5. Alright, so since this 2.5 is less than 5, okay, so from here I know that initially it was binomial, right? Because you have N, you have the P. So since the NP is less than 5, alright, it is very small, and then the N is also large, which is 12,500. So instead of binomial, I will approximate it to Poisson. So I will write down the original distribution first, then it will be approximate to Poisson. Okay, so for Poisson, the mean is same as the NP. Alright. So this is my new distribution. So now to find Px less equals to 3. So I will write Px less equals to 3. Remember, right, x, here x means that when you see x, that is the binomial. But then now, instead of binomial, because of the NP is small, less than 5, then the N is large, which is greater than 50. Therefore, I have approximated to Poisson. So when Poisson, we have to convert the x into W. So I will write PW less and equals to 3. Now, here, binomial is discrete random variable. Poisson is also discrete. So we do not need to consider the continuity correction unless you approximate it to normal. Okay? So when PW less equals to 3, so for Poisson, right? So the Poisson formula is basically, let's say x is PO lambda. Then the probability of x equals to x, it will be E minus lambda x over x factorial. And the x starting from 0 until infinity means that from 0 until all positive integers. So due to that reason, PW less equals to 3 means that your W start from 0. Then you have to consider up to 3. So this will be the total probabilities. Alright, so now, okay, my lambda, when you compare, my lambda is 2.5. So now when you look at this formula, the E minus lambda is a constant. Therefore, I will take up the constant. I will write E negative 2.5. Then when x equals to 0, 0 factorial is 1. Okay, lambda to power 0 is 1. Therefore, first term will be 1 plus. So I will just consider this fraction, okay, for the other probabilities. So it will be 2.5 degree 1 over 1 factorial. So I will just write 2.5. Then plus 2.5 squared over 2 factorial. Then plus 2.5 cubed over 3 factorial for the last probability. Then at last I will get 0.758 equal to 3 significant figures. Okay, now B, find the values of EX and variance X and explain how your answer suggests the approximating distribution used in A is likely to be appropriate. So the EX, remember our X is binomial distributed, which is here. See, X is binomial distributed. So now I have to find EX. So means that is the mean and variance for the binomial distribution. Okay, so my EX for the binomial distribution is basically NP. So we have counted just now. 12,500 times 1 over 5,000, which is 2.5. Okay, then my variance X. So the variance for the binomial is basically NPQ. So since the NP already found, is it here NP? NP, I will just replace it by 2.5. That means it will be 2.5 times, okay, my Q is 1 minus P, right? So Q is 1 minus P. So it means that it will be 1 minus 1 over 5,000. So when you calculate this value, it's going to be 4999 over 2,000. And then it is 2.4995. Okay, since we need to count the values, then here I will just leave my answer in this form. And then now you need to explain how your answers, these two answers, suggest the approximating distribution in A is likely to be appropriate. Now look at the A. Okay, so for the approximating, we have approximated the binomial. Okay, or I would say that it is Poisson approximation to binomial. So my Poisson lambda is 2.5. Okay, this 2.5 is basically the mean. This is the mean and the variance for Poisson distribution. Okay, so obviously now when I consider my EX and the variance X, I mean for binomial distribution, the mean is 2.5, the variance when you round up to 3 significant figures. So this is basically almost 2.5 as well. Okay, so that's why the reason, or to explain why my answer will suggest that approximating distribution, is because the EX and variance X are almost equal. Okay, so they are both almost equal. Therefore, it is also almost equal to the lambda in the Poisson. Okay, now for question 7. Now, a random variable x has probability density function f, where the graph y equals fx is a semicircle. So this is a graph with center 0, 0. This is a center. And radius square root of 2 over pi. Here is 2 over pi. That means OB is also 2 over pi. Square root of 2 over pi. Because it is a radius. Alright, so now entirely above the x-axis, the graph, the fx is above the x-axis, whereas fx goes to 0. Now, A, verify that f can be a probability density function. So for probability density function, we have two conditions. Alright, so you can write fx is greater or equal to 0. This is the first. The second is the area. We know that to get probability density function, you need to integrate, right? So you integrate the whole function and the answer will be 1. So for the integration, it's also same as the area under the curve. That's why I'm proving the area now. So the area of f equals to area of semicircle. Okay, so area of semicircle is basically half pi r squared. So the r is the radius. So it's given radius is square root of 2 over pi. This is the r, then now I squared it. So when I square it, the square and square root will be cancelled off. Then now I will be getting half pi times 2 over pi. So all this can be cancelled off and get 1. Therefore, okay, this is the PDF. So f can be a PDF, probability density function. Right? So that's all for the A. Now, points A and B are points where the line x equals to square root 1 over pi meets the x-axis and the semicircle respectively. So basically the points A and B are given. This is A, here is B. Now show that the angle AOB is half 1 over 4 pi radians, and hence means use the previous, this is the first, this is the second, use the angle to get this probability. Okay, so now to get the angle AOB, so let's look at the diagram. AOB, here is the angle, and let this be theta. Okay, and now we know that at the point A it is square root 1 over pi, which means here is square root 1 over pi. Okay, and just now I have labeled the OB as the radius, right, which is square root of 2 over pi. So now when you look at this triangle, to get the theta, here is right angle triangle. I have the adjacent side square root 1 over pi and radius, which is the hypotenuse. So with the adjacent and hypotenuse, I'm going to use cos, which means my cos theta is going to be square root 1 over pi divided by square root 2 over pi. Okay, so now I will write here, let theta be the angle AOB. So cos theta is square root of 1 over pi divided by square root of 2 over pi. Okay, so from here, I can cancel off the square root, the pi. That means this is going to be square root of 1 over 2. Okay, or I would say that this is 1 over square root 2. So when you use your calculator in radians mode, it will be 1 over 4 pi. Okay, done the first part. Now, and hence, use this data to solve the probability. So, P x greater than square root of 1 over pi. Now, remember, to get the probability is same as the area. So now you need to get area under the curve, but it is greater than this x value, which means this is the area that you need to find now. So obviously, to get this shaded region, the area of the shaded region, you can use area of sector. Okay, this is the whole sector. Then you minus area of the triangle. Then you'll be getting the area of the shaded region. Okay, so I'm going to use that concept to solve this probability. That means this is area of sector AOB minus area of triangle AOB. Okay, so area of sector is basically half, right? If you use the formula, let's say this is R, here is theta. So area of sector is half R square theta. So now my R is this. Theta already found just now. Okay, so I will write down the formula first. I'll write half R squared theta minus area of triangle. We have a formula. Area of triangle. Alright, let's say I use back this triangle. Since I know the theta, alright, I know the data, then I can just use these two sides. That means it will be, let's say here A, here B. That means area of triangle is going to be half of AB sine theta. Okay, so when you look at this right angle triangle here, my A is OA, my B is going to be OB. Alright, so I will write half OA OB sine theta. So replace the R by the given value. The R is square root of 2 over pi. Then the theta already found, which is pi over 4. Then minus half OA from the diagram is 1 over square root pi. Then the OB is square root of 1 over pi. And then the BOB is square root of 2 over pi. So square root of 1 over pi multiplied with square root of 2 over pi. After that, sine pi over 4. Okay, so when you need to calculate this, make sure you change the mode of the calculator to radians. Then the first one, square and square root, will be cancelled off. Right? Then the 2 will be cancelled off. The pi will be cancelled off. That means you are getting 1 over 4. Then minus half. Now, when you calculate this square root, you can just combine. So it will be square root 2 over pi squared. So I will say it is square root 2 over pi. Okay, I do want to write square root pi squared. Then sine pi over 4 is basically 1 over square root 2. So now you can further simplify by cancelling the square root 2 from the second term. Then at last you are getting 1 over 4 minus 1 over 2 pi. So then to get the probability, you can just count this value will be 0.0908. Okay, so that's the solution for this question. Okay, now question number 8. A new light was installed on a certain footpath. A town councillor decided to use a hypothesis testing to investigate whether the number of people using the path in the evening had increased. Okay, before the light was installed, the mean number of people using the path during any 20 minutes period was 1.01. After the light, this is before, okay, after the light was installed, the total number n of the people using the path during 3 randomly chosen 20 minutes periods during the evening was noted. A. Given that the n was 6, find a Poisson distribution to carry out the test at 5% sequence level. Okay, so this 20 minutes, the mean number is 1.01, and now you are considering 3 of 20 minutes period. Okay, so means that now, first of all, before you carry out the hypothesis testing, I need to get my new mean first. Because 1.01 is for any 20-minute period. Now you are considering 3 same period. So therefore, you have to times 3. And then I will get 3.03. So now my H naught, I will write population mean the number of people equals to 3.03. And then now this is to investigate whether the number of people had increased. So when it has increased, that means it will be greater than 3.03. Okay, so the rest I will just rewrite. Okay, now in this test, it is 5% sequence level, so alpha is 0.05, and then the n was 6. So now be careful with this, because here is greater than. Alright, so I will write down my rejection criteria first. Reject H naught if px greater equals to 6 less than alpha value. Okay, alpha value will be 0.05. So the sign here, greater equals to 6, is depending on your H1. So if your H1 is less, that means you are counting x less than equals to 6, right? So please take note on this. Then now I need to count what is my probability, x at least 6. We know that this is Poisson distributed. Okay, so before I calculate this, I will write down my Poisson distribution first. My x is going to be Poisson 3.03. Then now px greater equals to 6 is going to be, now just now I have given you the formula, x is Poisson lambda. Then px equals to small x, it will be e minus lambda x over x factorial. So your x start from 0 until infinity. This is the formula. So now you need to count at least 6, the probability of at least 6. So it's not practical for you to count 6, 7 and on until infinity, because we don't know when to stop. So you can just refer to number line 6 onwards. Alright, 6, 7, 8 and so on. I will just use total probabilities minus up to the previous probability. The previous probability will be up to 5. Okay, so I will minus 5, 4 and so on. So from this number line, I will say that it is 1 minus p x less equals to 5. So now px less equals to 5, it will be px equals to 0 until 5. Okay, and then now by using the same method, this e negative lambda is constant, therefore I will just factorize it. It will be e negative exponential negative 3.03, because my lambda is 3.03. Okay, so now the first one again, 0 factorial is 1. Any number degree 0 is 1. So I will write 1 plus, then when px equals to 1 means that it will be the number itself over 1. So I will just write number itself, so which is 3.03. Then when px equals to 2, then I will start replacing the x in this expression, the fraction. So it will be 3.03 squared over 2 factorial plus 3.03, oh I miss out, this is 3, okay, 4 and then 5. So this is going to be power 3 over 3 factorial plus 0.03 power 4 over 4 factorial plus 3.03 to the power 5 over 5 factorial. Okay, so when you calculate all these probabilities, it will be 0.08697, and then now I round up to 3 significant figures, it will be 0.0870. Now, we need to compare with alpha value. Alright, so obviously this value is greater than 0.05. So here I will write it is greater than 0.05. Therefore, when greater than 0.05, I will not say reject H0, but we have to say do not reject H0. So now you write since Px greater equals to 6 is more than alpha, alright, the decision is do not reject H0. So when do not reject H0, okay, so it means we cannot conclude this, alright, then you can just say there's insufficient evidence to say that it has increased. Okay, so now your conclusion, you can just write there is insufficient evidence at alpha is 5%, so 0.05, to conclude that the mean number of people had increased, right? Because that is our concern. You want to check whether it had increased or not. Okay, so done for the A. Now B, later a similar test at 5% significant level, same alpha value, was carried out during another 3 randomly chosen 20-minute periods during the evening. So it means that now the lambda remains at 3.03 because again 3 20-minute periods. Okay, now you need to count the probability of a type 1 error. So to get the type 1 error, we need to know the critical region. Okay, because type 1 error means we need to reject H0. But then from the previous calculation, we know that where x less greater equals to 6, it is do not reject H0. Okay, therefore now I need to count when it is Px greater equals to 7. What happened to that? Whether it is reject H0 or do not reject H0. So Px greater equals to 7. It will be 1 minus Px less equals to 6. Okay, just now our x is Poisson 3.03. Alright, so now for this, 1 minus Px less equals to 6, you can just use 1 minus, rewrite everything there. Okay, just now we count until 5. Alright, because I didn't show you what is the total probabilities before you use 1 minus the probabilities. I didn't count this value. I didn't show you the sum. So that's why I will just write it down and just recount again. So here will be E negative 3.03. Then rewrite everything from the previous. Okay, so I will just write up to here. Then I add on when the x equals to 6. So here will be 1 plus 3.03 plus 3.03 squared over 2 factorial, 3.03 cubed over 3 factorial plus 3.03 degree 4 over 4 factorial plus 3.03 degree 5 over 5 factorial, then add one more. Okay, then from here you will get 1 minus 0.96496. Then at last you are getting 0.0350. So this value is less than 0.05, less than your alpha. which means when you look at the definition here, okay, the rejection criteria, we reject H naught if the probability is less than alpha. So as long as the probability is less than alpha means that you are going to reject H naught. So which means now we are getting less than alpha. Okay, so I will just say we reject H naught when x greater equals to 7. And now by looking at the question here, probability of type 1 error. So probability of type 1 error is probability of rejecting H naught given that H naught is true. Okay, H naught is true means that, we go back to the hypothesis testing, H naught is true means that the lambda value is 3.03. Okay, that's why I have used this 3.03 to get the calculation. Then from here I found that when x greater equals to 7, the probability is basically less than 0.05, which means it will be rejecting H naught. So it is tally with this definition, the probability of rejecting H naught. So this is basically same as P of x greater equals to 7. I have done the calculation here. Then I will just write down this is 0.0350. Okay, so this is the solution for part B. Now C, state what is the meant by type 1 error in this context. Okay, so type 1 error means that we reject the H naught, alright? So it's mentioned in the, it's given in the definition here, reject H naught. So what does it mean by reject H naught? Go back to the H naught here. When you reject H naught means that we cannot accept this statement, H naught statement, but we have to accept the H1 statement, which means the population mean number of people had increased because it's greater than 3.03. Okay, so I will write this. So type 1 error means the mean number of people using the path footpath per 20 minutes period in the evening had increased. Okay, type 1 error means reject H naught when the H naught is true. Alright. Okay, when it has increased. Now remember, this is to reject H naught, but then H naught is true. Let's see, what is H naught is true? So H naught is true means that it is 3.03. So it means that it's actually not increasing. Alright, then I have to continue my statement here, had increased when it has not. Because when H naught is true, right, means there's no increasing, there's no increment. But then reject H naught means that it had increased. So this is the meaning of the type 1 error in this context. Alright. Now D, state in contrast what further information would be needed in order to find a probability of type 2 error. Do not carry out any further calculation. Okay, so now refer back to the definition of type 2 error. Probability of making type 2 error is basically probability of do not reject H naught given that H naught is true, is false. Okay, type 1 error means given H0 is true. So now type 2 error means given H0 is false. Okay, so if H0 is false, then we need to know what is the actual lambda value. Because in your H0 here, in your H1 here, okay, if your H0 is false, means that this is wrong, then you have to accept this, accept the H1, which is greater than 3.03. So means we need to know what is the actual lambda value. Okay, that is the first. So further information needed. A true mean value. Okay, the first is a true mean value, means that a true mean number of people. Okay, the second is do not reject H0. So if do not reject H0, then we need to know what is the number of people, right, using the path, which is the critical region. So the second will be number of people using the path per 20-minute period in the evening. Okay, let me check back the question over here. Alright, so we need to get these two information in order to calculate the type 2 error. Okay, so these are the solutions for D. And we have come to the end of the video. Thanks for watching. Right, please subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.